All right. So today we're looking at sample proportions. So the whole idea, just like if we were finding out some statistics about Australia, you're not going to necessarily interview everyone in Australia. Well, we do every 4 years. It's called the census. But let's say we can't be bothered. So we're just interviewing a small sample of people, and we're going to use that. We're going to pretend that that's proportional to the whole Australia. So sample proportions are where you've got a bigger population, but you're only taking a small sample, and you've got the statistics that you calculate are going to be slightly different just because you are taking a smaller sample, which means that if you have, certain extra outliers, like a single extreme value, it doesn't matter as much for a big population because it kind of gets absorbed into the rest of the data, but it definitely would matter if you took a sample. So when we're taking a sample, we have certain requirements to say that we're allowed to estimate that it's normally distributed in the sample. NP has to be greater than or equal to 10, and NQ has to be greater than or equal to 10, and then we can say it's representative. The textbook doesn't actually specify this. And let me double check in the syllabus, extension, sorry, just looking it up. While I look that up, the average, the mean for the sample should be the same as the average, the mean for the whole population. And, you can assume this given these certain requirements to say that it's normally distributed. You should be able to assume, you can assume that the mean of the sample proportion is the same as the mean of the whole population. And, oh wow, sorry, I'm just looking at the syllabus. It doesn't get very specific. But we have the limitation that if we're taking a smaller sample from a larger population, yes, outliers do throw it off. So the standard deviation is going to be smaller. So when we talk about that, the standard deviation, we have a new formula for it. So you know how normally the standard deviation was the square root of the variance, so it was the square root of NPQ. This time we divide that by n, which gives us the square root of NPQ on n squared. The n's cancel out, and we end up with this baby. So yeah, the standard deviation for the sample is going to be smaller than the standard deviation for the whole population. I'm just trying to figure out how much of it, how into this I should go with you guys, because the textbook, the syllabus isn't that, okay. I'm just going to work through questions, and if it requires us to talk about it a bit in more depth, then I'll do that then. So we've got 5 coins, and we've got heads, tails, heads, tails, tails. What's the sample proportion of heads in this experiment? So for this experiment, we had 2 heads out of 5 things. So that's the sample proportion. 10 cards from a standard pack with replacement records the suit. The proportion of spades in this sample, so just in case you don't know, spades are these dudes. So we've got 1, 2, 3, 4. So it's 4 over 10. And question C, we've got 12 items and we want to see if they pass or fail. So let's have a look. Oh, this was heads. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 over 12 is the proportion that pass. So you'll see, especially from question 1, you would have, well, obviously we couldn't have 2.5 heads. But the sample proportion is obviously slightly different. But given the criteria that NP is greater than or equal to 10, which here it obviously is not, it equals 2.5, you can assume it's normally distributed. So I would only assume that the sample proportion P hat was truly representative of the actual probability for greater n. You know, for NP greater than or equal to 10, P was technically a half. So you would wanted n to be greater than or equal to 20 to assume this was to assume the proportion was representative of the whole thing. So to assume the proportion is also normally distributed. Because we like the normal distribution, because